Hi kids, welcome to Module 3, and you have a new workbook. So hooray, you have two new workbooks. And so Module 3 is continuing always to talk about multiplication, division, but we're really introducing and talking the whole time about fractions. And so what is a fraction? You probably remember from 3rd and 4th grade because those years are where you get to know what fractions are and hopefully understand them. But just a quick review, a fraction is kind of a relationship between these two numbers. You'll have a top number and a bottom number and a line in between them. And we're going to talk a lot about what the line means and what the numbers mean, and things will change, but that's okay. The big idea here is that not only are we going to understand fractions and work with them, but we're going to make equivalent fractions right away in Lesson 1. And we're going to use a number line to do this, and we're going to use an area model to do this, and we're going to use numbers. Talk about a jam-packed lesson. So let's take a look at what is in the book. Here are some sample problems. First of all, in your notebook, in your notes, you might want to have a number line. So a number line is a line with a bunch of numbers on it. Look for the arrows. It goes on forever in both directions. You can label the number line in any type of counting that you want. So a really great number line to look at right now is a ruler. A ruler is a number line. This ruler has kind of a finite space because it begins at 0 here on this little tick mark, and it ends at 12 on this little tick mark. And again, when I say the little marks here, I might say a hash mark or a tick mark. It's just going to be any mark on the number line. And what it does is it signifies a point on the number line. And so some tick marks are longer than others. So if I'm making a number line on my own, I might say, okay, well, if this is 0 and this is half, I might do a small tick mark there, but I might do a longer tick mark for 1 in the same way that the 0 here is longer, then it's got a super short and a longer and a super short and kind of a longer. And they go on like this so that you can count more easily. There's a lot of counting going on with these number lines. The next thing that we're going to talk about is this area model. The area model is designed to help you create equivalent fractions by drawing vertical lines followed by horizontal lines. It's really important that you establish this pattern right away, that you're going to always start with the up-down, that's vertical, and always finish with the horizontal or sideways. Start with the tall up-down vertical, and the second, when we create that equivalent fraction, we will be drawing the lines sideways. Just as a reminder, I will be using the words numerator and denominator a lot. So remember that that is the fancy word for the top number or the bottom number, because there's always going to be like, are we selecting the numerator? Okay, so how many are shaded? But what about for the numerator? How about the ones that aren't shaded? So you have to kind of think about, well, what part is being selected? That is generally going to be this numerator part. Unless we have a blank in the denominator spot, then we will be looking for that one. Anyway, we will be creating sort of these multiplication problems as we create with our area models. That's coming. And we will also be looking at different sized sections. So in the top part, you can see that this is a big section because it's half, and then the whole is over here. And this is actually 0 and 1 whole over here, but the sizes of the sections are smaller. That's because we're talking about fourths on the bottom line instead of halves on the top. And another thing, just be consistent. If you're going to create with first vertical lines, you've got to be consistent. Second, do the horizontal. Okay, now those are your notes. There's a lot more to this. If you have a chance, or if your teacher prints something for you, I really like this form from Class Playground, and I printed it and I'm photocopying it for my students, and that we can cut them out. But if you don't have them, and in years past we have used just plain pieces of paper that are easily foldable, and when you fold them, you can create your own equivalent fractions and just draw a line and label your own units. So it's really up to you. These actually are kind of the right length for the book. And the hardest part is when something is not even. Like, notice that I'm folding these in threes, and there's a tiny little bit hanging off on the end, but the idea is that when you hold it next to a one whole, if you look at all three pieces of your thirds, or to be equivalent, if I have 2 halves and 3/3, that those are the same length. And they are the same length as one whole. And so we're going to talk a lot about equivalence that way. So keep those little fraction strips handy if you have them. Mine are approximately 6 inches long, if you can see there, 6 inches. And it's roughly about an inch, and I used a paper cutter for these, lucky me. And if you have to use scissors, it may be a little wickety-whack, but that's all right. So you just try your best. Anyway, we are going to, I had to print these because I have no more books. So we're going to jump right in. Here we go. So use the folded paper strip to mark points 0 and 1 above the number line, and then we're going to make fractions. So if you have your paper strip or one of these, you can cut this one out, but of course this is going to be bigger than the ones that are the 6-inch pieces. These fit better with your papers and your books because it's the right size. So use the folded paper strip to mark the points 0 and 1 above the number line. So place your fraction strips here, mark the end points on the number line, and we're going to put 0 and 1 above the number line. This is 0, it hasn't started yet, and this is 1, that's the whole. Okay, now we did that. But we're also going to mark 0 halves, 1 half, and 2 halves below it. So what do we need? We need a little tick mark here in the middle. Why don't I need another tick mark? Well, because I already have one. This is the same location as 0 halves. This is the location for 1 out of 2 pieces, and this is the location of 2 out of 2 pieces. That's all we have to do on that top number line. It's just to get you used to counting in fractional units, okay? Now, on the next activity, it says draw one vertical line. Vertical means straight up and down the middle of each rectangle, creating 2 parts. Notice that they give you squares, okay? That's a sign of things to come. Rectangles can be squares if they have the attributes of a square, so we'll be talking about that later. But we're going to create 2 parts by taking your hand and just doing a free hand stripe right down the middle. Do all 4 in one step, okay? Try your best to make them pretty much mostly in the middle. Don't labor over it, don't cry, just try for the middle. Now shade the left half of each, okay? Shade the left half of each. Quick little scribble, quick little scribble. Remember, it's not art class, it's math class. Just get this shaded, okay? Left half, not the right. No, your left and your right. Now we're going to partition, look at this word part that says part, with horizontal lines to show the equivalent fractions. 2/4, 3/6. We're going to do each one has a different fraction, 4/8 and 5/10. Then use multiplication, so we have to do this step now, and then this step. So we already did that. We did this, we did that. We're going to partition, we're going to use multiplication. So there's a lot going on in each of these problems, a lot to unpack. Use multiplication to show the change in units. let's look at the first one, okay? Now the first one shows the 1/2 that we already shaded, okay? So that's the part that we're going to transform this into the equivalent fraction, okay? So always start with your beginning. And then now we're going to partition with horizontal lines to show 2 out of 4 parts. Now, if this is 1, but I draw this line, now I have just created 2 that are shaded. I didn't change the shading at all, but I've created these 2 parts out of 4. Okay, so I made, instead of 1 group of 2, I made 2 groups of 2. And the 2 groups of 2 makes 2 shaded out of 4 total. Okay, I hope that's pretty clear. Let's do the next one and then you'll see if how much you understand. This one's done, but I need to do 3 out of 6 parts. So how do I do that? Well, instead of drawing 1 line, I am going to draw 2, but it's going to be, we're going to make thirds out of this second rectangle. Why don't they say square? I don't know. They just want you to know that these are also rectangles. So let's take this, which was originally 1/2, okay, and then as we did right here, we're going to take our 1/2, draw a little bit longer line this time, and instead of creating 2 halves, we're creating 3 groups of 3, okay, or 2 groups of 3, sorry, my bad. 2 groups of 3. 2 groups of 3. And then we have 1 times 3 is 3 when we multiply with fractions. And aren't they just throwing a lot at you here? When you multiply with fractions, you go straight across with the numerators and straight across with the denominators. 1 times 3 is 3, and these are the 3 shaded. And 2 times 3 is 6, and this is the total. And so fractions represent different selected pieces, but the bottom number represents the total number of pieces or parts. Okay? So let's take a look. Now, as soon as you created these horizontal lines, you made 6 little boxes, 3 of which are shaded, even though we didn't change the shading. See, we're not changing the shading at all, we're just changing the number of parts. Let's do this one. Now, when we have an even number, like we're going to have 4/8, 3 is not even, it's odd, that's why we had to be careful with our sections. But if you have an even number, then you can always do half the top and half the bottom. So I always do split it in half, then half the top, half the bottom. Okay, now take your half, 1/2, and then we're going to do 1 times 4 and 2 times 4. Look for the pattern to start developing. 4 are shaded out of 8 total parts. 4 shaded out of 8 total. 4/8 are shaded. 1/2 is equivalent to 4/8. 1/2 is equivalent to 3/6. So you're making equivalent fractions. Bravo, by the way. Now, if we have 5/10, I need to make 5 sections going across, which is done by drawing in 4 lines. So they have to be even narrower than these here. So 1, 2, usually the 3 in the middle, make sure this third one's in the middle, and then 4, 5. 1, 2, 3, 4, 5 sections, okay? Because now I need to have 5 that are shaded and 5 that are unshaded. So take that 1/2, do your 1/2, but times what? How many sections? 5/5. And now I have, instead of 1 group of 5, I have the 2 groups of 5 for 5/10. And again, 5 shaded out of a total of 10. So that is how you do number 1. Now, for number 2, you're taking your fraction strip. Again, this one's really better because it fits on this line. It's a 6-inch piece of paper. Mark points 0 and 1, 0 and 1 above the number line, and then 0/3, 1/3, 2/3, 3/3 below it. Look for where the tick marks go. And now remove that and create your little, your labeling. 0 out of 3 parts, 1/3, 2/3, 3/3. Okay? Follow the same pattern as problem 1, but with thirds. So because we're starting with thirds, let's take our vertical lines and put 2 lines to make 3 sections. And again, it's not art class, but it is math class, and we need it to be somewhat precise. So 2 lines down in each one to create 3 equal sections. Shade one of them. Just keep it on the left. Shade 1, shade 1, shade 1, shade 1. Okay? Now let's take our 1/3. And you could even write 1/3 because that's the thing that we're starting with. In each one, if you want to recognize what the pattern is, we're starting with the same fraction each time. This is going to create an equivalent fraction, starting with that 1/3. But what are we going to do here? We're going to draw one line that's horizontal, okay? Creating 2 horizontal parts. So instead of one group of, or 1/3, we have 2 out of 6. 2 are now shaded out of 6. This 1/3 is equivalent, has the same value, has not changed in size as 2 out of 6 parts. Let's do the next one with 2 lines creating 3 sections like a big tic-tac-toe board. Equivalent. Rewrite the 1/3, make the line a little bit longer. And now I have thirds. I have 3/3. So I have, that's a little too long, so I don't want to bump into the next guy. But we have 1 times 3, so we have 3 that are shaded out of a total of 9. This is equivalent to this one. Okay? How about here? We're going to use fourths. So halfway, half the top half, and then half the bottom half. 1/3 times 4/4. Now I have 1, 2, 3, 4 shaded out of 12. And again, this is an array. It should be familiar from 3rd and 4th grade. 3 times 4 is 12. 1/3 is equivalent to 4/12. Okay, and think of it also in terms of 4 out of 12. If I had 3 4s, it would make 12. That's just another way of thinking about it. And finally, we have fifths, so they have to be a little bit smaller. 1, 2, remember the third section's in the middle, and then 4, 5 at the bottom. So it's 1/3 times 5/5. Makes 5 shaded pieces out of a total of 15, showing that 1 out of 3 parts is equivalent to 5/15. It takes 3 5s to make 15. I hope that's pretty clear. And I have page 2. And so we're going to continue this same pattern, but now we're going to have 3/4. So let me take my fraction strip that I didn't make fourths, fold it in half, and then half the half. Okay, drawing a line down for each one. Make those stand out. Each one is 1/4, 1/4, 1/4, 1/4. Continue the pattern. So put that right next to this number line. A little tick mark there. Hold on, 0 and 1. And then don't forget the tick marks so we can fraction out this number line. 1, 2, 3 this time. let's label them in their parts. 0/4, 1/4, 2/4, 3/4, and 4/4. I hope you guys are noticing that whenever we get to the 1, that last fraction has all the parts. 1 is always equal to 3/3, 2/2, 4/4, 5/5, 100 hundredths. Okay? Now, for your vertical lines, I'm like, what's the word? Vertical. For your vertical lines, this time I want you to go half down, then half the left and half the right. Half the whole thing, half the left, half the right. Half in the middle, left, right. Middle, left, right. Now this time, notice that it's 3/4. We're not doing 1/4. We're shading 3. So it's not just 1. It's the second one and it's the third one. Try to just keep them in those lines. Can you just shade all the way across? Yes, you can, because this is going to be 3/4. Same here. 3/4. Same here. 3/4. Okay, now this one, we're going to take our 3/4 is our first fraction for each one, and we're going to draw that horizontal line. So we're going to make our 3/4 times 2/2. Okay, so now we're doubling what the 3 was. That makes 6 shaded parts out of doubling how many total parts. Instead of 4, we have 8. So now we have 6/8 as our equivalent fraction. Notice how the numerator changed on this one. Continue the pattern. Take your 3/4, and this time we're going to divide it into 3 sections with 2 lines horizontally. And so we have thirds, and then that's creating 9 shaded out of a total of 12. So our numbers are closer this time because we have a lot more shaded. Copy the 3/4. But what are we sectioning off into? 4ths horizontally times 4/4. How many are shaded? 12. How many are total? 16. Equivalent. Equivalent. Copy the 3/4, and now we need 5ths here. 1, 2. Look for the third section in the middle. 3, 4, 5. Times 5/5. 15 are shaded out of a total of 20, and we have an equivalent fraction there. Okay? And finally, that last one is our 6ths, or 5ths. We have 5ths here, 6/5. So one thing we noticed when creating fraction strips for 5ths, if I had a 6-inch piece of paper and I needed 5 pieces, then we figured it was about 1, 2, 3, 4. I think we did 1.25 inches, 1, and then 1/4, 2, there, and then 3/4 there. And so then we had about 1, 2, 3, 4. That totally did not work out. Oh no, it wasn't the inches. Oh gosh, it's been a long time since I did this. We use centimeters. All right, here we go. We try again. That's what it was. You take your 15 centimeters. 15 centimeters. And then just divide this up because we need 5. So it was about 3 centimeters a piece. That's what we did. 3, 6, 9, 12, 15. Here it is. All right. 1, 2, 3. 3, 4, 5. And then you can label your fifths. Oops. Yes, you can. 1/5 for all of them. And then put this right up here next to it, and 0 and 1 above, and then label each of those little parts with a tick mark. 1/5, 2/5, 3/5, 4/5, 5/5, 0/5, 1/5, 2/5, 3/5. It's just procedural. 4/5, getting used to counting and calling those denominators the fifths. Okay, oh, this is a great one because we have like 2 that are next to each other. And so what you might notice is when you have 6/5, well, what is that? That means that if I have my model is only in 5 pieces, 1, 2, 3, 4, 5, but I need 6/5. I go, well, here's a 5th. 1, 2, 3, 4, 5. Then I need a 6th one over here. And so what that extra model is for is to show you that sometimes you have fractions that look like this. Those are called improper fractions. In fact, I have notes somewhere. I'll probably put those on. Oh no, here they are. Look at that. I have notes about that. An improper fraction has what I just say. It's a gigantic top and then a smaller bottom. So 7/5 is an improper fraction. We'll get to all this stuff in future videos, but just know that, hey, this is an improper fraction. It means I've got like 5/5 here, but I have to add this 1/5 here for a total of 6/5. Okay, I hope that makes sense. So, so what are we doing? We're going to make 2 equivalent fractions for 6/5. So let's say you have your half and your half. Okay, then you take your 6/5 and you multiply it by 2 halves, and what you end up with is 12/10. That is the equivalent. So notice that when I multiply or double both the top and the bottom, I end up with this equivalent fraction, which still has a larger top than the bottom. Okay? Let's do fifths again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of this one has to be shaded because we need 5/5 here, and we need the 6/5. Okay, so we have our 5/5 plus our 1/5, and that makes 6/5. But we have to make an equivalent fraction. So if you can, now this is your choice. You can choose to not do halves here. You could do thirds, you could do fourths, you could do fifths, sixths, tenths if you really want to challenge yourself. But what you want to do is create the sections and then draw that into your calculation here. Okay, so if you're going to do thirds, then it has to be all the way across. Okay, you can do thirds, but it has to be all the way across. So then how many are shaded? 18. How many are in a set? 15 are in one set. Okay, and so that's going to be the total equivalent fraction for 1. 15/15 is equal to 1. And as it is, so is 5/5. Okay. Anyway, I always hope you guys are learning something from these, or at least being entertained if I flub something. So come back on a future video and click subscribe, and I'll see you on the next one. Good luck with these, and we'll see you on lesson 2. Bye.